Okay, let's do a quick review over powers and exponents and how we can simplify when we have the same base. So let's just remember that when we have parentheses, we are going to expand whatever is within the parentheses. So the base is really -6. This 3 is attached to both the negative and the 6. So we're going to expand the negative as well as the 6. So when we combine -6 times -6, we get 36 times another -6, and we get -216. And just to double check myself, that gives me 36. That's 18 and 21. And there goes the bell. Okay, in this problem, the negative is just dangling out front. We're just going to carry it down. The 4 is only attached to 10, so I'm only going to expand the base of 10. So I'm going to have a negative, and then I have 4 zeros, so a 1 and 4 zeros, and I have -10,000. In this one, the negative is just dangling out front. My exponent only is going to the 7, so 7 is my base. So I'm going to carry down this negative out front, and then I get -49. On this one, my base is -5. I have 4 -5s. The negative is included, so I'm going to expand. And then I'm going to multiply -5 times -5, and then I'm going to do it again. And this gives me a positive 625. Okay, now let's take an expression where we have repeated multiplication and write it as an exponent. Here we have the base of 3, and we have 3 of those, and then we have a variable x multiplied twice. In our second one, we can write it 2 ways. We have 1, 2, 3, 4, 2 y's. We could also break it down and look at it as 1, 2, 3, 4 2's, so 2 to the 4th, and then we would have 4 y's. Either of these is correct. Do not make the mistake of writing it that way. This only says I have 1 2 being multiplied when I really have 4. Here, the negative is included as the base, so we have to include and use parentheses, so -8 within the parentheses raised to the 3rd power. On this one, we have our negative just dangling out front, and our base is 7, and we have 6 of those. Here, we want to make sure that anything raised to the 0 power is 1, except if we have an understood negative dangling out front. So 9 to the 0 is really 9 over 9. That really gives me positive 1. In this example, we have the understood negative out front, and then our base is 9 over 9, but we get the -1. In this case, 0 is the power to both the negative and the 9, so my base is -9, and so this gives us positive 1. So be careful when we have parentheses and when we do not. Okay, remember, if you have a negative exponent, the rule says to reciprocate it to the opposite location. So here we have 5 to the -2. We're going to reciprocate it to the denominator, and then we have to have a 1 in the top. If you want to go ahead and evaluate, we would get 1 over 25. In our second example, this time the exponent is negative, but it's in the denominator. We're going to flip it to the numerator and say 2 to the +4, and that gives us positive 16. In our third case, we have 3 just variables. So we have 3 factors. So if it's positive, you're going to keep it where it is. If it's negative, you're going to move it. So here we have b to the -1. We'll move to the denominator. Now we're in the denominator. A squared is positive, so it's going to stay. But the factor of c is going to flip or reciprocate to the numerator. No more negative exponents. Okay, now we have the product rule. So if you're multiplying like powers, so we have x to the m times x to the n. Really, we have many x's being multiplied, and all we're going to do is add the exponents. So we went from 2 factors to 1 factor. That is what simplifying is all about. So here we have 5 c's times 3 more c's, so that is c to the 8th. Here we add exponents, and we get m to the -2, but we can't leave it as a negative on the exponent. In this case, we have z to the -4. We reciprocate and have 1 over z to the 4th. In this case, we have coefficients as well as variables, so I'm going to rearrange. So I have my like factors. So 2 times 3 is 6. And then we have A times A times A times another 5A, so that's a total of 8A's. Okay, let's rearrange and put our coefficients together and then our variables. 4 times 2 is 8. Then we're going to add -1 plus 1 is 0. We're never going to leave something raised to the 0. We know it's 1, and 8 times 1 is just 8. Okay, and our last one here, -3 times 2. And then we have k squared times k to the -5th. We're going to multiply -3 times 2 and get -6. We're going to combine our multiples of k and get k to the -3. This -3 is only attached to the k. This -6 has an understood positive exponent, so we're going to leave the -6 in the numerator, and we're going to bring k to the -3 to the denominator and make it positive. Okay, the last one, quotient rule. We're going to go from 2 factors to 1 factor by subtracting the top exponent minus the bottom. So here we have x to the 4th, 7 minus 3. Here we have a factor of k, and it's -4 minus 2, which is the same as -4 plus -2. So I have an exponent of -6. We're going to reciprocate, and we're good to go. Here, we're going to break this apart. We have a coefficient, and then we have our variables. We're going to simplify this fraction. We get 4, and then we have an a factor, and then we're going to say 3 minus 5. That's the same as 3 plus -5, so we get -2. The -2 is only attached to the a, so the 4 remains. It has that positive 1 exponent. We're going to reciprocate and put the a squared in the denominator. And our last one. We are going to simplify this fraction. They both can be divided by 6. So this is going to give us 3/4. Here is where you need to make sure you pay attention. Now, when we start out, we're going to always start with our variable in the numerator. Now, we may need to adjust it in the end, but start with it in the numerator. So I'm going to say 5 plus -3. Oh, this is division. My bad. Let's back up a bit. I guess you guys were wondering, what is she doing? This is 5w to the 5th over w to the -3rd, my mistake. But we still start with the w in the numerator, but this time I'm going to say 5 minus -3, which is the same as 5 plus 3, and gives me 8. So I don't have to adjust it. So I apologize for that error. Okay, so when we separated these, we did the coefficients times our variables, and they were dividing, and so we applied the rule, the quotient rule 5 minus -3.